Their quick check 5.1. Question number 1 is explain why gases can be compressed easily. Their gases can be compressed easily because gas particles are very far apart from each other. There is a large amount of empty spaces, about 99.9%, between the molecules of a gas. When external pressure is applied, these particles move closer together, which decreases the volume of the gas. This property allows gases to be compressed more than solids or liquid. Next is, what is Joule-Thomson effect? There, the Joule-Thomson effect is the phenomenon in which a gas cools down when it undergoes a sudden expansion without exchanging heat with its surrounding. During this rapid expansion, gas molecules require energy to spread apart. They absorb this energy from the surrounding, which causes the surrounding temperature to drop. This cooling effect is used in refrigerator systems and in air conditioners. Next is the volume of 84 gram of gas is 8 cubic decimeter at minus 90 degree centigrade under 7 atmospheric pressure. Calculate the relative molecular mass of the gas. There given data क्या है, प्रेशर हमारे पास 7 atm, वॉल्यूम 8 क्यूबिक डेसीमीटर, टेम्परेचर माइनस 90 डिग्री सेंटीग्रेड. इसको हमने केल्विन में कन्वर्ट कर लेना है. आर की वैल्यू हमें मालूम है, तो फार्मूला हमारे पास होता है PV इज इक्वल टू nRT. यहाँ से हम n की वैल्यू निकालेंगे PV ओवर RT फार्मूला अप्लाई करके. वैल्यूज पुट करेंगे, हमारे पास n की वैल्यू हमारे पास आ जाएगी 3.73 मोल. अब कैलकुलेट रिलेटिव मॉलिक्यूलर मास mR. फार्मूला हमारे पास क्या होता है, मास ओवर मोल्स. तो मास हमारे पास कितना है 84 ग्राम, मोल्स हमारे पास कितने आ गए हैं 3.73. तो हमारे पास रिलेटिव मॉलिक्यूलर मास कितना आ जाएगा 22.5 ग्राम पर मोल. Their quick check 5.2. The first question is to improve the quality of a gasoline means petrol. Straight chain hydrocarbons in the gasoline fraction of petroleum are converted to branched chain ones. What could be the possible reason? There, to improve the quality of gasoline, straight chain hydrocarbons are converted into branched chain hydrocarbon. This is because branched chain hydrocarbons provide better combustion and engine performance compared to straight chain. Their straight chain hydrocarbons like N-pentane have larger surface area, which leads to stronger London dispersion forces between their molecules. These stronger forces reduce the efficiency of combustion. In contrast, the branched chain hydrocarbons like neopentane have smaller surface area, which means weaker London forces. As a result, they combust more efficiently, produce fewer engine knocks, and improve fuel performance. That is why branched chain hydrocarbons are preferred in gasoline to enhance fuel quality. Next question is, which forces are present among the molecules of the following substances CCl4 and SiF4? There, अगर हम बात करते हैं कार्बन टेट्राक्लोराइड की, इसका स्ट्रक्चर टेट्राहेड्रल एंड सिमेट्रिकल होता है. Each CCl bond is polar due to electronegativity difference, but the overall molecule is non-polar because of its symmetrical shape. अगर आप इसके इंटरमॉलिक्यूलर फोर्सेस की बात करते हैं, ओनली लंडन डिस्पर्शन फोर्सेस आर प्रेजेंट. और अगर हम बात करते हैं SiF4 सिलिकॉन टेट्राफ्लोराइड, तो डेयर स्ट्रक्चर इसका टेट्राहेड्रल एंड सिमेट्रिकल होता है. ईच SiF bond is polar but the overall molecule is non-polar due to cancellation of dipole moment. इंटरमॉलिक्यूलर फोर्सेस इसमें सिर्फ लंडन डिस्पर्शन फोर्सेस होती हैं. बोथ दीज सब्सटेंसेस means carbon tetrachloride and silicon tetrafluoride are non-polar molecules and hence only exhibit London dispersion forces. Next is differentiate between ID मतलब instantaneous dipole, induced dipole and permanent dipole intermolecular forces with example. There, ID forces are temporary attractions that occur between non-polar molecules due to momentary dipoles. These are the weakest intermolecular forces. ये ब्रोमीन CH4 और हीलियम जैसे मॉलिक्यूल्स में पाई जाती हैं. अगर हम बात करते हैं परमानेंट डाइपोल फोर्सेस की, दीज आर अट्रैक्शंस बिटवीन पोलर मॉलिक्यूल्स ड्यू टू परमानेंट डाइपोल्स. दीज आर स्ट्रोंगर देन ID फोर्सेस. ये HCl और CHCl3 जैसे मॉलिक्यूल्स में पाई जाती हैं. देयर क्विक चेक 5.3. फर्स्ट क्वेश्चन इज, कैन द CHF3 molecules make a hydrogen bond? Explain why or why not. There no CHF3 cannot form hydrogen bond because the hydrogen atom is bonded to carbon, not directly to fluorine. For hydrogen bonding to occur, hydrogen must be attached to a highly electronegative atoms like fluorine, oxygen or nitrogen, which is not the case here. Next is show hydrogen bond between two molecules of ethanol. There in ethanol, the hydrogen atom of the OH group of one molecule forms a hydrogen bond with the lone pair of the electrons on the oxygen atom of another molecule. This occurs because ethanol contains an OH group which satisfies the condition for hydrogen bonding. इसका स्ट्रक्चर यानी हाइड्रोजन बॉन्डिंग हमने यहाँ दिखा दी है, आप इसको ड्रा कर लीजिएगा. नेक्स्ट इज डिस्क्राइब विच फोर्सेस आर प्रेजेंट इन द फॉलोइंग and arrange them in increasing order of boiling point. There propane has London dispersion forces और ये वीकेस्ट होती है. क्लोरोइथेन हैज़ डाइपोल डाइपोल फोर्सेस एंड लंडन डिस्पर्शन फोर्सेस. इथेनॉल हैज़ हाइड्रोजन बॉन्डिंग, डाइपोल डाइपोल एंड लंडन डिस्पर्शन फोर्सेस. मतलब इसके अंदर स्ट्रोंगेस्ट फोर्सेस होती हैं. तो बॉइलिंग पॉइंट ऑर्डर क्या होगा? इथेनॉल का बॉइलिंग पॉइंट सबसे ज़्यादा होगा और प्रोपेन का सबसे कम होगा. नेक्स्ट इज द बॉइलिंग पॉइंट डिफरेंस इन ईच ऑफ द फॉलोइंग पेयर इज गिवन. Explain why the difference decreases as the size of the molecule increases. There, as molecular size increases, London dispersion forces become stronger. These start to compete with hydrogen bonding in alcohol. Therefore, the boiling point difference between alcohols and their corresponding alkanes becomes smaller with increasing size. Next is molecule of ethanoic acid means acetic acid exists in the form of dimers in pure form but not in aqueous solution. How can hydrogen bond can explain this? There in pure form ethanoic acid molecules form dimers by making two hydrogen bonds between them. In aqueous solution water molecules form hydrogen bond with ethanoic acid breaking these dimers. Hence dimer formation is not favored in water. Their quick check 5.4. Arrange the following liquids in increasing order of surface tension. Give reason. Their surface tension depends on the strength of intermolecular forces. Methoxymethane. Methoxymethane has weak dipole-dipole forces. Next is acetone. Has stronger dipole-dipole forces due to higher molar mass. Next is ethanol. Has hydrogen bonding, which is the strongest force among the three. Increasing order of surface tension. इथेनॉल की सरफेस टेंशन सबसे ज्यादा होगी और एसीटोन में ये सबसे कम होगी. नेक्स्ट इज व्हाई डू यू थिंक टेट्राक्लोरोमीथेन मींस कार्बन टेट्राक्लोराइड हैज हायर विस्कोसिटी देन क्लोरोफॉर्म but less than ethanol. Their carbon tetrachloride is a non-polar molecule but it has a high molar mass which leads to a strong London dispersion forces. These forces makes its molecules stick together more, increasing its viscosity. Chloroform, although a polar molecule, has weak dipole-dipole forces and a lower molar mass, so its viscosity is less than that of CCl4. On the other hand, ethanol forms strong hydrogen bonds which are much stronger than dispersion forces, making its viscosity higher than both CCl4 and CHCl3. Thus, the viscosity order is CHCl3 की विस्कोसिटी कम है CCl4 से और इसकी विस्कोसिटी कम है C2H5OH की. मतलब C2H5OH की विस्कोसिटी सबसे ज़्यादा होगी, CHCl3 की सबसे कम होगी. Next is the viscosity of honey is higher than water. Explain why. Their honey has a higher viscosity than water because it contains large sugar molecule that can form multiple strong hydrogen bonds. These strong intermolecular forces cause the honey molecules to stick close together, making it flow very slowly. In contrast, water also forms hydrogen bonds, but its molecules are much smaller, so they can move more freely and flow easily. Therefore, honey has higher viscosity due to strong and more extensive hydrogen bonding. Next is which of the following is more viscous, glycerine or hexane? There glycerine is more viscous than hexane because it contains 3 OH group which allow it to form multiple strong hydrogen bonds between its molecule. These strong intermolecular forces make the flow of glycerine very slow. On the other hand, hexane is non-polar hydrocarbons and has only weak London dispersion forces, so its molecules can move more freely. Therefore, glycerine is much more viscous than hexane due to strong hydrogen bonding. Quick check 5.5. Which of the liquid in each of the following pair has a higher vapor pressure? Alcohol versus glycerine. There, glycerine has 3 OH group, so it forms stronger hydrogen bond than alcohol. Therefore, alcohol has higher vapor pressure than glycerine. Next is petrol versus kerosene. There, petrol molecules are smaller and have weaker London dispersion forces than kerosene. So, petrol has a higher vapor pressure than kerosene. Next is mercury versus water. There, water form hydrogen bond while mercury has strong metallic bonding. So, water has higher vapor pressure than mercury. Next is which one in each of the following pair is more viscous? Glycerine or kerosene? There, glycerine is more viscous than kerosene due to its ability to form strong hydrogen bond. Glycerine contains 3 OH groups, which allows it to make extensive hydrogen bonding between its molecules. On the other hand, kerosene is a non-polar hydrocarbon and can only exhibit weak London dispersion forces. Because of these weaker forces, kerosene flows more easily, whereas glycerine flows slowly due to its strong intermolecular attractions. Hence, glycerine is more viscous. Separate portion of acetone and water at the same temperature are poured on your hands. Acetone feels colder. Account for this in terms of attractive forces. There, when acetone and water are poured separately on the hand, acetone feels colder than water. This happens because acetone has weaker intermolecular forces, mainly dipole-dipole interactions, whereas water has stronger hydrogen bonding. Due to weaker forces, acetone evaporates more rapidly. As it evaporates, it absorbs more heat from the skin to convert into vapor, which causes a stronger cooling effect than water. That's why acetone feels colder. Next is why evaporation gets faster at high temperature. There, evaporation becomes faster at high temperature because the kinetic energy of the molecule increases. As temperature rises, with more kinetic energy, more molecules are able to overcome the intermolecular forces that hold them together in the liquid state. As a result, greater number of molecules escape into the gas phase and the rate of evaporation increases. Next is why do we feel cool near the bank of a river? There, we feel cool near the bank of a river because water is continuously evaporating from the surface of the river. During evaporation, water molecule absorb heat from the surrounding air to gain energy for escaping into vapor. This absorption of heat causes the air near the river to become cooler. When this cooler air comes into contact with our body, we feel a cooling effect. Quick check 5.6. First question is why food cooking is difficult in the areas with high altitude. There, at high altitude, the atmosphere means external pressure is lower than at sea level. As a result, water boils at a temperature lower than 100 degrees centigrade. Since boiling occurs at a lower temperature, the heat available for cooking is also reduced. This lower temperature is not sufficient to cook food properly and thoroughly, which is why cooking takes longer and becomes difficult in high altitude regions like mountains. Next is the food cooks faster in the pressure cooker. Explain. There, in a pressure cooker, steam is trapped inside the sealed container, which increases the internal pressure. Due to this higher pressure, the boiling point of water increases above 100 degrees centigrade, often reaching up to 120 degrees centigrade or more. This elevated boiling point allows water and steam to hold more heat energy, which is transferred more efficiently to the food, causing it to cook faster and more thoroughly in less time. Next is why the boiling point of water is higher than that of ethanol. Although both have hydrogen bonds, there both water and ethanol form hydrogen bonds, but the strength and number of these bonds differ. Each water molecules can form up to 2 strong hydrogen bonds due to its 2 hydrogen atoms bonded to a highly electronegative oxygen atoms. In contrast, ethanol can form only 1 hydrogen bond per molecule because it has only 1 OH group. This makes the intermolecular forces in water much stronger than in ethanol, resulting in a higher boiling point for water. There, quick check 5.7 का पहला क्वेश्चन, why solids have very low compressibility and expansion. Their solids have very low compressibility and expansion because their constituent particles like atoms, ions or molecules are tightly packed. These particles are held together by strong intermolecular forces which leave very little space between them. This close packing means there is no room for the particles to move closer together when pressure is applied or to move further apart when heated. Their movement is restricted to simple vibration. Next is what is meant by habit of a crystal. The shape of a crystal in which it usually grows is called habit of a crystal. If the condition for growing a crystals are maintained, then the shape of the crystals always remain the same. If the condition are changed, the shape of the crystal may change. For example, a cubic crystal of NaCl become needle-like when 10% urea is present in its solution as an impurity. Next question is, why solids do not undergo translatory motion? Dear, solids do not undergo translatory motion, movement from one place to another, because their particles are fixed in their position. They are held together by very strong intermolecular forces that prevent them from moving freely. The only motion the particles in a solid can perform is vibrational motion around their fixed mean position. Their quick check 5.8. First question is, name the properties of liquid crystal in which they resemble solids. Their liquid crystal resemble solids in the following properties. They have a parallel ordered arrangement of their molecules. They show optical properties like crystals. They are somewhat rigid. Their properties are anisotropic, meaning they vary with the direction of measurement. Next is, mention the properties of liquid crystals in which they resemble liquid. They can flow like liquids. They show viscosity like liquids. Their molecules can move and spin, although with restrictions. Next question is, which property of liquid crystals make it possible to use them in temperature sensing device? There, the property that allows liquid crystals to be used in temperature sensing device is their ability to change color with a change in temperature. This change in color is a result of the altered arrangement of their molecule as they are heated or cooled.